Okay, so what should we do today? Where we want to work on, or what's yeah.
Well, we have a few things. I think, let's see. Should make an agenda for the meetings, to be honest.
I
I
was
think Michael
hoping.
was working on some suggestions for like the status messages and
Mhm.
like the menu. I think Rob, you shared a mock-up today, which is quite
Yes,
nice. I
one.
thought you actually programmed that because it
No,
looks
no,
so
no,
real.
no, 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 not
I
yet.
was like, oh,
I
that looks pretty
just
real.
first the idea and to see how it looks like, and then make it. And that was basically Michael's idea to rotate the screen, but automatically we thought if we do with an IMU
Hmm.
manually or automatically. I think if you connect an IMU, you can automatically detect if it's what orientation it is, and it can automatically switch. That will be ideal.
Like a phone.
Yeah, like a phone.
Is it really
Auto
ideal?
rotate.
Because I have auto
Yeah,
rotate on my phone. I have it
yeah,
turned off because I really don't like it.
yeah. Sometimes it's ideal, and sometimes it's not. I
Yeah,
mean, every
yeah.
so often you're looking at a photo, and you're going, "Please, please rotate for me."
Yes, it doesn't
You
go.
know, so it might maybe one of the options we can put in the menu is fixed
Yes,
or automatic.
I think so. No,
I
sure, we
also
need that. Yeah.
Yellow's point last year, last meeting about having vertical text. Um, I understand, yeah, it's hard to, your eye doesn't automatically read the word. Um, I thought one of the possibilities was that instead of having a word there, for example, on the main menu, you would just use that which is becoming a universal symbol for a menu,
Oh,
which
I think
is
so.
those three horizontal lines.
Mm-hmm.
Hmm.
Like in hamburger, they call it.
Instead of text just on the middle
Yeah.
button. And then once you're in the menu, you'll have the up and down arrows
Mm-hmm.
for scrolling and the right arrow for selecting.
Mm-hmm.
And well, maybe I could.
Yeah,
And then to go backwards, you could just have a menu item that's exit, which would have a left arrow associated with it.
Mhm.
Mhm.
Yeah, did you have
Right.
time to look at the code that from the what Michael shared with us for the menu? It was quite interesting code.
I think I missed
That
the
was a
sharing of the
while ago.
code.
That was the code for the he used for another program, and it's in GitHub. And I checked it out, and it's quite interesting how they made it, or how you
I
made
actually
it.
adopted it from somebody else's code. It was called Gem, a good enough menu.
Hmm.
But I found it lacking in some ways, and so I modified it for my purposes.
Mm-hmm.
Um,
All right. And no, I didn't really take a look. I just noticed the message. Usually messages send at midnight for me, or I don't get notifications, so I kind of missed
but
the.
but the menu system that you pointed me to, that one uh, has links to you can has web searching built into it, and had more features.
Mm-hmm.
Which one was that? Was that the one that Rob sent?
Yeah, but I sent the first a longer time ago. It's it's already built for the M5 stack, I think.
Right.
Right. Yeah, there are some settings that you can put in as well, like already configurations. But I'm not sure how we can easily integrate that into our system. Because our menu
Right.
system is like together with like the way we render the screens and like
Mm.
handle the data from our sensors. So it's already a bit different, and the way that we handle like the menu interactions is well technically the same because we can still say like, oh, there's a button there, and if you press on the button in this specific screen, then this will happen.
Right.
So in a way, we already have what we kind of need.
Mhm.
So yeah, I didn't look at the specific menus that were
Okay.
linked.
No, you've been doing other things, so that's also important. I was hoping that Josh could show us some icons, but he doesn't seem to be interactive. So
Yeah, I don't think he was. He hasn't messaged anything.
no,
last
nothing.
week.
Let's see.
That's all right. Like it's not a high priority. It's nice to have it. soon, but
For visual impression, I think it's important.
it is well. It is a must for the release, of course. But
Mhm.
like for this specific week, like if he's not here today,
No,
then
that's true.
it's okay.
Yeah.
I hope he can be here next week though.
Mhm.
All right. What were the other things? I think last week we mentioned like we can work on the screen. Like
Yes, I would like to. And
Um,
by the way, I'm sending out. I'm still putting some parts together for all of you, and then probably by Tuesday I will send them out.
Oh, good.
And then it needs some, how would you say that, description, how to put things together. But basically, I like you to figure it out yourself and come up with probably better ideas or different ideas on how to put it together.
right.
Some pictures what I've done, and then you can take that as a kind of guide. There's one problem with the board is that the I2C connector is reversed. It's top and bottom. It's the footprint is supposed to be from on the top, but it was taken from the bottom, so the pins are reversed. I can explain that later. That's very simple.
Okay. Is that an issue for the hardware then?
It's
for the
an
connection?
issue if you connect to the I2C port. That's all. If you have
Okay.
an extra external, for example, the MPU can be external on the core
Oh,
too,
okay.
and then
And
you need another pin.
so the plug is polarized, right?
Yes.
So you would have to just twist the wiring, all 4 wires, right? Is that what you're
Yes,
saying?
but if you twist the connector, the female connector, then it's fine.
Okay.
Okay. So the that there's no external connector on that at the moment. Is that one of those? Is that like a Grove?
Yes, I prefer the Grove instead of the small. How do you call them? The quarry.
Quick. Oh yeah,
The quick,
that Spark Fun uses.
yeah, I agree with you. The quick one, pulling it in and out, yeah,
Not with our fingers, the big one.
yeah, yeah, I know.
I have the problem with it.
You have to grow your fingernails out a little bit
Yes.
more to get that.
Alright.
So also, so what I was one of the things that came to mind was when getting the hardware and putting it together is, Louis, you had, a way of, generating pulses for the, to mimic the detector, even though it wasn't ideal, it's, kind of something that we need, for logging and, so, and you just had I don't know what board that you used for that.
Well, it was just a Adafruit ARM ARM Cortex M0s. They call it the see, I'm just looking at it right now.
Is it a feather?
Yeah, you can use a feather too. It's fine.
It's a itsy bitsy. It's like the feather, except it doesn't
Yes.
have the feather has the external power management, so you can hook up a battery.
Right.
So it's basically the same thing. It's but it could be any of their like the 32-bit ARMs.
Yeah, I use an an M5 Atom for it. It
Right,
runs the
right.
same code, so it's
Yeah, I
fine.
ran it on the
But
ESP.
they are this big, they're very
Yeah.
small.
Hmm.
They're cute.
Yeah, so when we get to that point, you know, we could share the code and that would, you know,
Well, the code is there. I mean, I
It's,
think
it's already on,
On
but
GitHub.
it's in my GitHub, so
yes,
under
Okay.
support.
you just get a link from Louis.
Yeah.
Okay.
Yeah,
Post that right now.
Yella and me both used it already, and it works fine.
it works
Great.
fine. Yeah.
The only problem is it goes only to 1200 CPM. That's the
Well,
maximum.
there's,
But it's
if you hook up a button, you can toggle it from slow to fast.
yes, but
Okay.
that's it.
Yeah.
Mhm.
Well, okay,
1200
yes.
and that's it.
It's
I'm
already,
the version I'm working on is a real hardware tube emulator. So
Okay.
it gets a high voltage FET, and it really gets the pulses correct.
I
Oh,
see,
good.
okay.
Mhm.
Be interested in seeing that.
Yeah.
Yes. I talked with Joseph about it, and he suggested some small changes, but basically he agreed with me that's a simple way to go, and it should work. Yeah.
Sounds good.
That's good.
Yep.
Is there a way we can like mock the GPS data as well, or is that harder to do because the
Yeah,
Geiger counter just pulses and
The pulses, that's
GPS is like a
simple.
whole bunch of
yeah, no, well, the GPS, we can just give you a stub that that basically moves around a little bit.
yeah, something like that.
Sure.
If we can make that, that'd be quite useful, I think.
Just drive around in circles.
I'm in the circle.
And record all the output and just like repeat that.
So basically you just like an if def or something like that. So then when it gives you data ready, be an update every second, and there's just going to be, you know, just changing the data that comes from the GPS, but without actual GPS. So it'll just give you, you know, I can cook something up like that, so you can work in your basement or away from the window.
Mhm.
Mhm.
All right. Well, it's that's would be nice to have, I guess.
Yeah, that's a
Um,
useful tool to have, I think.
hmm There was also an issue that we discussed last week with the fonts.
Mhm.
Because we want to use the font 7 from the M5 stack,
Yes.
but that's comes only in one size. So, Rob, were you able to?
No, I didn't look at it, but
Fine.
it's very
Okay.
simple to do, because we can put any FFT font on the how to say, in this SPFF, I think it's called, that area.
Oh, right.
In the
Yes, yes.
I use it all the time for all different fonts, and you can make anything you want.
Yeah, that's a good idea. So, yeah, maybe you can.
Yeah, I
that
can
for,
do that.
next-
I'll put it on my list.
All right.
After I send out the boards to you, all of them. And
Sounds
I
good.
think we got already about 20 orders coming in for the production. So
Ooh.
we have to
Should
start
make
working.
haste.
Yeah.
Yeah, I was working on the logging again today as well on the train. Yeah, I do have some questions because the log string that was used on the Zen, which is also used the Tiny GPS. I'm just wondering, like, the precision. I'm not sure what the precision is in the current data, and
I mean,
also the
how-
altitude. Like, should we the altitude on the Nano, was it in meters, or
Yeah, it's in meters.
because I think this one is in millimeters, isn't it?
It shouldn't be, but let me check.
Or is it? I'm not sure.
The raw data is in, I believe, in
Meters.
millimeters, but
The raw data, yeah.
but I thought I was sending you I mean, let me check that.
And also the position, because the data currently in the GNSS data, which is the
Yeah.
struct
Mm-hmm.
which the GPS connector worker provides, is all in 32. So I would expect like
Oh,
a double or a float. So
okay.
currently we could do the conversion in the GPS data, or currently I have in the log aggregator where I'm creating the data lines.
Right.
I'm doing the conversion over there, so I'm not sure which is more preferable.
Okay.
I think maybe
This is probably something that you and I should work together interactively, just to make sure that there's that I understand what you require and you understand what I'm sending. So I don't know if you want to set some time aside of one, sometime this week or whenever.
yeah, anytime, like through the chat, or we can have a call.
Yeah.
Or
Yeah, exactly. So anytime that we're not busy.
Yeah, I can let you know. Like maybe later today, because it's like in somewhere in your afternoon.
Yeah. Okay.
I also, let's see, the nano code, because it used the Tiny GPS. Tiny GPS also provides a latitude and longitude string, which I'm not sure, because the current library that we used doesn't provide a string, of course.
Oh, it could provide.
And
It does.
It could provide a
does it?
string.
It can.
It does. Really?
Well, it provides a whole bunch of information that, like a whole bunch of stuff that I'm not using. It's quite complete. So it's just a matter of figuring out what's needed, and then from that figure out what, from what's available in the actual SparkFun API, and just, basically just massaging the data to get what we need to log and to present.
But you have to, I think you have to be careful. There was something that Robin mentioned, that you flip the minus and the plus, and then you add the north and the south to it. There was something in the code I saw. You should check that.
For the log string, you mean?
Yeah.
Yeah, that's what I already did, so that is okay.
Oh, okay.
But the thing is, I currently checked the SparkFun uBlocks library, and it only has like get latitude, get longitude, and high res longitude, latitude, but not like longitude, latitude string or anything.
Okay, well, we can.
But that's no issue, of course.
Yeah.
We can just it's actually easier to work with an integer or a double, or whatever we can make from it, because we also have to do like a calculation for a fixed mode. Like, is it in fixed mode or not? We have to do some checks. But what I was trying to say is, I remember from the Big Geek cast, I had to do a conversion from, what was it again? From degree in minutes to decimal degree.
Yes.
So I'm now wondering if the latitude string and longitude string were already converted degree in minutes, because on the cast I had to convert it. So I'm not sure if we have to convert those, like the data that we get, we have to make like a degree in minutes value to send to the API, or sorry.
I mean, to the logging.
For the logging, yeah.
Or also later to the API, if for the Wi-Fi.
I think that the API actually expects the decimal degree version, because I had to do the conversion, right? So
I see.
I'm not sure what we should be logging.
Okay, so yeah, well, we can scrub through that.
Yeah, well, we can always like change it if the log is incorrect. So I'm just raising the issue that we should be taking a look at it once we do the logging and run some testing, etc. So we know what to kind of expect.
Okay.
Did I read some?
Yeah, go ahead.
Go ahead.
No, you
I
first.
just, I did I read somewhere that you guys were also based your GPS code on somebody's tiny GPS library? Or was it just the SparkFun library?
No,
we're just
but
using the-
basically, yeah, Louis. Go ahead, Louis.
Yeah. Yeah, so the tiny GPS library strictly uses the NMEA standard strings, and they really don't provide really good information. Meanwhile, uBlocks, the receiver maker, has their own protocol, which is entirely in binary. It's basically, it's not human readable.
Right.
And the nice folks at SparkFun came up with a really complete library that implements basically all of the library.
Okay.
Just for a laugh, this is the manual. I don't know if you can see. It's
There you go.
500 pages of good fun.
Yeah.
I can imagine.
And
By the
that's
way,
what I'm very-
we are running out of time very soon.
Okay,
Maybe Jelle
so
can after Stuart
Tiny
can, start
Tiny
again.
GPS out, SparkFun in. That's
Okay. Got it.
Okay.
Right. Tiny GPS was in the Nano.
In the
and
Nano,
in
yes.
The first version.
Yeah.
Yes.
Years ago, I had played around with GPS modules and Tiny GPS and wound up rewriting a lot of the code, but it still didn't get to the better format.
Mm-hmm. But you're using the Plus version, the Tiny GPS Plus.
No, this was probably 10 years ago.
Yeah,
or
but
I don't
that's
know.
when we made the Nano too.
Yeah.
Yeah.
Yeah, I don't remember any of the details.
I can imagine.
All right. So you're going to restart the meeting or?
Yeah, I think we're
Uh,
gonna run very soon out of time. So maybe we
Okay.
should just close and start a new one before.
Okay.
Yeah, it
say
says
something.
13 seconds here, so
Okay.
Okay,
I'll
good.
make a new one. Send
Yeah.
link.
Good. And
Sounds good.
and please record and send the file to me later. That's good.
Yes.
Okay. Thank you.
Yeah,
Okay,
so we were talking about
GPS, but I think that's to do to just make sure that the information coming from the GPS gets to the log in the right format and to the screen in the right format. And I think that's just one of those things that's like just looking at both ends and meeting in the middle somewhere.
So you had the Geiger tube emulator to have the software version, and Rob is gonna come up with something even better than that. And for a GPS emulator, were you gonna just do that in software on the core, or were you gonna do that external and feed the pulse stream?
I think it's too hard to do it external because I'd have to emulate the uBlocks protocol. Right back to that 500 pages of good fun. So it's just going to be a stub function that you compile in, like a compile time. Just set a if-def, and
Right.
it's just going to give you, like driving around circles around your house. Or within a range of like a few kilometers here and there.
Right.
though
and
it
just-
would be nice to have like an external thing that you can like connect and disconnect and see
Mhm.
how well it reacts, or well,
Yeah.
it's not like it's not that important.
No,
I mean, you can also have like a Geiger counter internally, so but then you can't really test the code itself.
Mm.
So, but yeah,
Yeah, but
don't
the
know.
Geiger counter externally is a little bit different with the interrupts. There you have to be careful with.
yes.
Would it be possible to have like a GPS module and just read like everything that's coming in and just storing that and having like a huge list of whatever it's sending and just put that in an external device like another controller, and then just loop through the text.
Capturing bit for bit, basically capturing the serial stream.
Yeah,
Hmm.
on one like somewhere, and then just storing that in a program and just loop that all the time, and then maybe you have like a
Yeah.
minute or something, you loop up 1 minute.
Mhm.
I think something like
See, the
that.
problem is that the API or the library sends a request to the GPS module. Give me what you have.
Oh,
So, well, we could do that. It's just, you know, like the little storing thing could just read the serial stream and just pick out the message type and just assume that it's the be an interesting project. I'm just wondering. I think the pulse generator probably has priority if that's okay with you.
oh
It
yeah,
might be
absolutely.
something,
Yeah.
it might be something I could take on too, and once I
Mhm.
get to understand the bits, what the messages are, um, I could put it in
Yeah.
a teensy.
Yeah, yeah.
And that's a serial interface, correct?
That's right.
Yes. Yeah.
Okay.
9600.
No, actually it's 38.4. No, I just kicked it up.
Oh,
Oh,
okay.
nice.
Yeah. So so the the data that you're getting, the position data is actually quite up to date. So and the module computes a new solution every 1 second, and so the at the rate of 1 second, you make the request and you get the fresh data.
Right. But so with this data, you're not producing velocity and acceleration or anything. You're just saying this
No.
is at this point, this is what we've got.
Yeah, at this point, yeah, there's a lot of information coming out of that module that we're just not using. So, I mean, it can
Right.
do, it can do what they call, northeast or sorry, like north, south, east, west, and down attitude. So, so the actual velocity in 3 axes, as well as what they call it kinetic solution, where you're not too sure. You're not getting a signal, but you can interpolate from previous, and that's, it's meant for automobiles.
Right.
Mhm.
Yeah, would it be
It
useful to
was also
use those
for-
data?
Well,
Because
not
if
sure I
we
want to go there.
if we're on a drive and it's,
Yeah.
I don't know, maybe it is not reliable enough.
Well, for instance, if you go into a tunnel, but then what does that do to the data? Because all of a sudden you're not just at ground level, you're underneath.
Hmm.
I mean, in some areas, yeah, it would make sense to keep. And the next question is, how reliable is that kinetic solution over a period of time? So if I'm just going under like a short tunnel, like in town, yeah, then like if it's only a few hundred meters, not a big deal.
Right.
But if it's if it's a longer tunnel, like in like in the mountains or something like that, I mean, that the more I think about it, the more I think it's a bad idea, because the data points that you're going to get are from underground. So presumably there's more material there. There's more disintegrations. Therefore, the radiation is going to be higher. So, and then if you look at it on the map, the map is basically it's a straight down, right? It's a plan view, but there's no way of showing that data point was taken underground. So I'm not too sure.
Right, because the altitude is not reliable enough, then, or
Yes, exactly.
Well, the altitude is reasonably reliable. The module, there's a correction that's applied, right? The satellites kind of orbit a virtual, they call it an ellipsoid. I'm going to get the terminology wrong because I'm not
That's okay.
I'm not a geographic scientist, but it's basically it's a it's a geometric shape that, so they compute the solution with respect to a an ideal geometric shape, and then apply a model correction that is basically an agreed upon actual lumpy shape, to account for mountains and hills and all that, and that corrected shape is what I'm sending to the recording. So it might be out by a few meters, but not the difference. Just testing it here, the difference between the ideal shape and the and the corrected shape is about 200 meters.
Mm.
All right.
So, anyway.
In that stream of data, does it also include the fact that it's doing estimations on certain things? When it's doing estimations, is that something you can add to the data? I don't know. You're trying to be compatible with back versions of this, though.
Right. So yeah, you get what they call a dilution of precision, and it's basically the module estimating from the satellite data, and the the elevation of the satellite, because there's ionospheric distortion that causes a little bit of a delay that's significant.
Right.
So they give you a degree of precision, and basically anything less than let's say 100 or so is quite good, and that figure gets better the more satellites you have in view, and the more
Right.
satellites you have within like a reasonable range of azimuth. So if it's close to the horizon, then that dilution of precision gets. I have no idea how they do that stuff. It's quite amazing. But the long and short is that we can get a fairly good fix within I'm going to suggest 10 or 20 meters radius,
Right.
horizontally, and then maybe a few again maybe a few tens of meters vertically, like altitude.
Right.
Yeah. Mhm.
So I mean my immediate goal is to match what the Nano does. So,
Right. Exactly.
All right. That sounds like a plan. All right. So GPS done. Then the screens.
Yella.
Yes.
Do you keep track of the issues on the list, or how do you keep track? Because you look like in your mind.
In my mind. No,
Because
yeah.
because it's useful that if we put it on GitHub, so we can all see the issues and give comments on it. And
Right. Yeah. I think the GitHub. We wanted to use that later when at the point that we have like the working device, and then we can add issues like, okay, now we have to fix this.
Okay, good.
I think we're almost at that point. I would like to add the actual logging handler, because I tried to add it today, but the log aggregator that I was also working on. So the log aggregator picks up all the workers and creates one reading, and that one reading is the one that we can send to the log file by a log handler, or send over Bluetooth, because it also uses the same string. You don't want to build a string like 10 times or something. And the data in the log aggregator, we can also use that on the screen, or like it has a timestamp and all. Kind of depends. Like, I have to. No, actually, the log aggregator is for the logging purposes, so not for the screen. So that would be for the API as well. So the API doesn't get like the the log string itself, but does get the other data like the timestamp and the CPM. What else? Yeah, GPS. That's it. I think the API can also get the battery level, right?
Yes, that
So
would be very useful. Battery
I
level.
think we
and
skipped that on the Geigy cast because
Yes,
there was no data
we put that
available.
in the battery. Yeah,
Right,
because
okay.
the cast cannot read the battery,
No, indeed. Okay.
but we can read the battery on an M5 stack. That would be very useful. We can track that.
All right. Then I will add that soon. All right, then for at least my plan for next week will be to finish up the logging, this time for real. Maybe I'll at least make more progress. And then I will add the log handlers. My plan was to have a log handler for the journal as well as for the like the manual logging, like the start log on the drive as well as on the survey, which might use probably the same handler. So I can just enable the handler will then create the file, etc. Then there was the GPS time and the real-time connector, like the real-time data.
Real-time clock.
Oh, the
Real-time
real-time clock.
yeah.
Yeah. The
I think for
Yeah,
the logging, we should be
yeah,
using the GPS data.
what-
Is that
I
yes.
think Louis wanted to say something about the real-time
Yeah.
clock.
Well, the only okay, so for logging, for sure, we use the GPS time because that's well known. My idea for using the real-time clock was only for naming files if we need to put a timestamp in the file name before GPS data becomes available.
right?
So
Okay.
it's a very short period of time between power up and GPS acquisition, which with this module is somewhere around 30 seconds. It's actually the longest would be like a few minutes if it's completely a cold start and it's been off for a day or so. But if it just turn it off, let's say you're driving somewhere, you turn it off when you get there, you turn it back on when you leave and go home, then it should pick up the GPS very quickly. So the only time you really need it is that short time between power up and when it actually gets time, and then at that point use the GPS time to update the real-time clock, to resynchronize it, and then don't look at it again till next time you reboot.
Does the real-time clock have a small battery backup?
Yes, it
Yes.
does. Yeah, it's built into the Core 2.
Oh, because I unplugged the battery on the Core 2 and it said low voltage. I assume, I didn't know if that was a
no,
low
the battery,
voltage.
there's a tiny little, it's not even a coin cell, it's a tiny little thing.
That's inside
In
of
the Core 2.
the core.
Yeah.
The core board.
All right. I was surprised because I didn't. I did notice that it has the little vibrating motor in there.
Yes,
the
it
Core 2.
does.
Yeah.
But is it something that would
didn't know
need more testing? The real-time clock still works if you take out the battery then?
No, yeah, that's work because there's two batteries. One is
Okay.
the little battery, and there's a small, tiny one on the board.
So I could set the real-time clock, and then even if the battery, we turn off the battery on the unit, it might trigger a low voltage indication, but the time may still be valid, is what you're saying?
Yes, if
Okay.
the
Yeah.
RTC is activated. I think Louis did some testing on
Right.
that.
And that's your indication that it's time to update the real-time clock from GPS once you get acquisition?
I think
Yes.
well, I think my plan currently or the suggestion I'm currently willing to make is we use the real-time clock for like always for the file log naming and for anything that we do internally with the time, and the GPS will always update the real-time clock once it's valid. Like so, if the GPS has a valid time, we will use that time. So even if you move like to a different time zone, the GPS would, I guess, pick up the new time for the new time zone. I'm not sure how that works.
Well, the GPS only gives you UTC.
UTC. Okay, then we
So-
always use UTC. Then it's always fine. So
Right.
can we also get like time zone data from the GPS?
No, I
Right.
don't think so. It doesn't do it.
No, because that's time zone. I mean, if you look at the international dateline, it's, you know,
It's a mess.
it's a
Okay.
mess. You have a half hour. We have a province here that's on the half hour. So it's too arbitrary.
Yeah. Okay. Well, then let's skip that.
Yeah.
Yeah, I think it's absolutely easier to just work with UTC. So, but still. So for the real-time clock, we will use the GPS. So we just update it with the GPS value. Like maybe the GPS value is, well, we'll just assume that it's always more accurate.
Well,
Maybe
it has to
the
be.
real-time clock is like a little bit faster or slower because of like
Yeah.
the internal clock.
I just anecdotally, I mean, I let it sit around for a week when and it drifted by about 1 second. So
Right. Yeah, that's what I kind of expected. So we can just update it with the GPS value whenever it's like off by a second.
The GPS time is down to the microsecond, and otherwise GPS wouldn't work. So,
Right. All right. Yeah, I'll be updating that, and then we can use the real-time clock times for like everything that we do internally. And then for logging, we use the GPS time because well, for logging, we also use like the GPS location and all the other things for GPS. So we just use the same time as well.
Yep.
All right. Okay. I think that's it for me. Is there anything else someone wants to add or raise an issue? Perhaps is there something that one of you wants to work on this week?
I'm still diving. I'm still, trying to actually, you have the map of the code, Rob, that you've been working on?
No,
draft?
not yet. It's it's coming.
Okay.
It's,
So I'm still
no
just
guarantee.
trying to sort my way through the code. I mean, the test, I just wanted to do a push and a pull to just, work through that path. That's why I just saw the rounding thing. It was just a test so I can get back into using GitHub again. Thankfully, I have my son. He can help me too, as well as Rob, with Git stuff.
Yeah, right.
But I was just going to go through, just continue to go through the code as I have time available.
Mm-hmm.
okay, well, I'm just going to work on that pulse generator. That's and just basically come up with something a little bit more versatile.
Right.
Mm-hmm.
Sounds good.
And once we have the circuit boards and stuff, I can put together a prototype. Then I can really get a handle on things like possibly doing an external GPS emulator or whatever.
Yeah. Oh, one, I'm just thinking about putting these things together. That's a wonderful opportunity to take lots and lots of pictures.
Yes.
And lots of notes, and then from that we can put together a nice assembly manual.
Oh yeah, if you don't mind to do that, I think you're very good in documenting this kind of stuff, Louis.
Yeah,
I mean,
okay,
I would like that you take charge of that. That would be great.
sure. Yeah,
Because
so
if you want to see good documentation, look at the blues.inout from the Node Hub. It's very nice done, and it's very easy to find stuff in there, and it's amazing organized. That is Ray's work. I mean, it's kind of amazing.
so where is that? Sorry, where is that to look at?
Blues.inout, and I can give you another link. It's the dev at blues.inout.
Yeah, if you could post that, I'd be interested to look at that as well. It's like the ideal assembly thing is Lego instructions.
Yes.
Apparently they've in all these decades they have never made a mistake or something like that in their assembly.
I tend to I would believe that because my grandson has a bucket of Lego and he's built some pretty intricate stuff, and it's really good stuff.
Yes.
It's
Yeah.
I used to build my prototype with Lego when I was around 12 or 13 years old, and
nice.
and when I was living in Amsterdam on a boat in one of the canals, my neighbor was working for Lego. He was designing once or two times a year, just one new stone, and that's what he could live off. They
Wow,
paid
wow.
him so well. What
Good
amazing.
times.
Yes.
Great
That
job
was-
though.
Yeah.
Yeah, I think so.
Well, now I don't know if you've read they're wrestling with the impact of plastic on the environment. Lego, the Lego Corporation.
I think so.
Yeah.
They
Yeah.
should make it for PLA and or something else. That,
Oh, the formula they have is just it's just right because it snaps together, but you can unsnap it without and it's very accurate. If you look at a Lego brick, every one of them has the Lego logo
Mhm.
printed in, and
every knot on the top. Even.
Yeah. Yes,
Yeah.
it's just
Yeah, I have it around always.
anyway,
All right,
Okay.
sorry for the
No.
good side trip though.
yeah.
Okay, we have other things to do because I like to start moving
good.
to already. So if that's fine.
Sounds good.
Yeah, I think that's it for this week's meeting then.
Okay.
For next week, yeah, we can just like pile up all the work we did upcoming week, and
Mhm.
then Louis, I will message you for the GPS.
Yes. Yeah. I'll try to find
Thanks.
a time to that works for you. Well, wait a second. It's the afternoon for you right now.
Yeah.
Okay.
So
So not too
maybe
late.
in like 3 hours or something. I
Okay.
have some stuff I have to do here. So
Yeah. Yeah. Okay. Yeah. So around my lunchtime. Okay. Fine.
Okay.
All right.
Okay.
Talk to you soon. Bye.
Yes. Bye bye.
Yes. Okay, because close. Okay,
Right,
bye-bye.
bye.